Hey guys, so today we will be revising again a new lecture on binary trees. What is this question? Question says same tree. We have two given roots of two binary trees P and Q. Write a function, check if they are same or not. Binary trees are considered the same if they are structurally and the nodes have the same value. Okay, so what can we do is that we have the root. Okay, okay, let us write like for bool left. Let's say left. Is it what? Is it same? It would give us is same. It would be given by this passing piece left cues left bool right piece right cues right. This function will give us the p whether it both are right. Then we have to just return if l- if if both are true. Okay. And also the root is should also be true, yeah. Wait. Let's see. Value, I think. I can do like this also. Why I'm not doing this? Then as a oh, let's see. Okay. If P null or let's say Q is null. Return if any of them is null. Return false. Not valid. Okay. So this gives us true. Okay. What did I do? Something is wrong. Okay. Should not be equal. What should be? Hmm. Wait. Left. Is true. Okay, wait. I think true, left true. Hmm. What the heck? Mm, left should be true, right should be true. Yes. Hmm. Okay. See, if P is null or Q is null, then it depends on the P and Q. See, let us think of P as null and Q as null. Okay, like the smallest is something which doesn't have null. When both are null, then we have to return true. Both are null true. If not, if one is null, another is not, then we have to like what is the base case? Base case is something which is the smallest one, which is the smallest one, and we have to see whether it is valid or not. Like smallest valid possible like input that is null. So what is the this is the base case. What is the return type we have to think? Let's say if it is null and it is not, then this is not possible to get. So it depends on P and Q. That is the difference and all. I think it's gonna work. Yeah. So pretty simple, pretty straightforward question. Not a very much like it is not that much of hard question. 572 lead code problem. Let's try to solve this. 572. Okay. It's given though I have written though, but let us okay. Let's try to code it again. So in this question it is told to do something, yeah? Let's understand this. So let us see what is the question tells. Subtree of another tree. Given root of two binary trees, root and subroot. Return true if the subtree is of the root with the same structure and node values of subroot and false otherwise. Got it. True if subtree of root with the same structure and node subroot. Okay. False otherwise. Subtree consists of node on the all the nodes descendant. Subtree of itself. Uh, tree could also be called subtree of itself, obviously. So obviously we're gonna solve it by recursion because it is the simpler to solve it by recursion. We have root and subroot, and we have to see whether it is a subroot or not. And root is also a subroot of itself. Okay. So what is the base case? Base case is the smallest. That is if root or subroot. Hmm. Any of them is null. Return root equal to subroot. What does it mean? Smallest possible valid input is both are null, or one null, another not null. So one another not null, this is false. Can't be possible to get a subroot. No, wait. If I think of this, like for example, both are null, then it is true. If root is null and subroot is not null, then it is false. If root is there but subroot is null, then also it is not. Null is nothing. If any of them is null, then I think my like either of them is null, like root is null or subroot is null, then we have to return what? False only. Null cannot be anything. So, okay, let's overthrow it. Let's move on. It doesn't have any example to showcase that. Number of root is a subroot of itself. Okay, null cannot be a subroot. There is nothing, there is no place written that the null can be a subroot. So it is false. Okay. Let's move on how to solve the left part and the right part. Let us think of that. So, what can we do is that might be there is a our left part has a root is equal to subroot, or the right part should have the root as a subroot. We have to check whether the left part has equal to subroot or right part. If either of them is true, then it's very good. Like the correct. So we are calling the same function for bool roots left part, comma, subroot. Let's say roots. Any of them will give us true. Yeah, bigger question. Let us try to write it because it will be helpful. Need to eat. Where is pen? Found it. So there is a root. Let's say root is something like 3, 4, 5, 1, and 2. Subroot, let's say 4, 1, and 2. We are in the root. We have called root's left part and subroot. It is equal. Then again left part also equal. Right part also equal. So return true. Either of them is gonna give us the true. Then it is true. Yeah, this is the thing. If left part is giving us true or the right part is giving us true, we have to see that. And also, if we found the like we have found the true, like we have found the root, then we have to find its left and right. So we are gonna call the is identical function, like we have already solved previously. Like we have found the root, now I have to see whether it is identical or not. Pretty simple. Why are we reading? So return, at last we have to return left might be true or right might be true. Any of them is true, we're gonna give true. So if roots is also a base case, roots, because see, for example, there is one element like root and subroot. Roots value equal to, because it is written that sub subroots sub tree sub I need to read row value, if they are equal, then we have to check whether we have to call the is identical thing. Base case. I'm writing the base case. Go to the, let us return. Uh, left left, if it should be true, And mm, one. Mm, mm. Roots right. Roots left would be true, yeah. Ah, okay. Mm, so all these errors come when you try to. Hmm. Um. Okay. Okay. Sorry. Pretty sorry. I understood. What did I done wrong? I understood what did I done wrong. Is that we have to return true, not like this. To put it here, and you have to return one. Why? Why did I do this? What does it help? See, for example, this is the same. Huh? So there is a problem with same. There is, if it is not like we have found values both are same. Yeah, roots value and subroots value are same. Like one, yeah. So one is matching, but it has left part, but it doesn't have left part. So it would return false, and it will return, and there is nothing to go back. And it will not come here. Left part and right part will not come here. So there is also another condition to add is that if they are or identical, we have to check in the if condition, because see, if they're not identical, yeah, also we can do like this. See, we have checked this roots value is equal, so we can do like something like this, like we don't need to check this because they are same, then only, and so this should be true and this should also be left and right but should also be true, then only can we can just return one, return true, only then we can return true. Either of them should return true, but return na something you have to return. Another wrong answer, bro. What? Okay, now you have to add now. This identical is added. Where is 3 0 5 8 4 8? It's not there, so I think we have to add that thing also, because there is nothing to check. Identical should have this, because what what is you are checking? Like you have to check now. Write this thing. This is the main thing that it computes. Like is identical. What does it does? It doesn't do anything. Nah, that's why put it this was. Okay, I understood. I understood like nicely. Hope you like this video. Bye. We'll be posting more videos. I couldn't. Bye. Bye. Bye.